Alright, okay, part 5. This hopefully should be the last part. All the statements, oh yeah, this is the put the proof in order thing. Okay, so we're given that DB is perpendicular. That's given. Oh, there's more givens. You know me, I like to get them out of the way. AB and CB, where is that? Where is it? Oh, it's in there. Well, then why oh, 1 and 2. There's the third part. Okay. Alright, so let's mark that stuff. 1's congruent to 2, AB is congruent to CB, and that's perpendicular. Okay. We're going to make congruent adjacent angles out of that. I hate that step. Alright, so that would be like DBA is congruent to DBC or something like that. Or sorry, yeah, DBA and DBC, that would be these two. Great. So we have both those marked. We're going to use that as a side or an angle, it looks like. Okay. We are headed for this, XB and YB. How many are there? 1, 2, 3, 4, 5, 6, 7, 8. So that would be 8. Probably going to be this. Oh, look, it's a two-stager. I have two different. Oh, cool. I bet you that's going to come right after one of these. Either that or that's going to be 7. Let's see which one it is. Step 7 to be one of those. And this is going to come right after the other one, whatever it is. All right, so there's not much else really to think about here. In terms of the no-brainer stuff, reflexive property is the only one that looks like it's going to be really easy. That's the one that's with the same thing. So reflexive is definitely going to go with that. There's no reason why I can't go next. Let's go ahead and call that step 4. Let's mark it on here. DB is congruent to itself. Oh, look, here's some side angle sides. I have side angle side on DAB, which is this triangle here. Great. So what can I harvest off of that with CPCTC? Well, not the last step, probably this one. That's angle A is congruent to angle C. Okay, and then the only thing left is the other triangles. Are the other triangles congruent by AAS, AXB, and yeah, they're AAS. So that's that. So I'm not wondering about this anymore. That was actually step 7, and the CPCTC is followed right where they're supposed to. Now you might want to go through this one in order and see that yes, it's actually true. But I'm pretty sure it is. Okay, I want to make sure I get done with this video. 6-part video has just never been heard of before. Okay, put this in order. Given x is the midpoint of blah blah blah. Well, that's only good for it's midpoint of both of these, so that's true, and that's true by definition of midpoint. Oh, supply the reasons, so I don't have the other column here. That's given. Definition of midpoint will tell me these other things are congruent here. I kind of like this kind of problem. Okay, and then when that's all done, I'm kind of hoping. Oh, the last step is going to have to be this one, right? 1, 2, 3, 4, 5, 6, 7. So this is number 7. It's a double stager, so that's not the last. That's not the only triangles congruent. Here's some more triangles congruent. So this one, I guess, would have to be before this one because this has to be last. DXE is congruent to GX or FXG. Two sides are already congruent there. But I'm guessing it's going to be the angle between. We have vertical angles 3 and 4. Yes, we do. There they are. That makes side angle side for that one. Great. So CPCTC helps on this one. For triangle DEF and F. Okay. DEF. Oh, DEF is a big one here. Okay, congruent to FGD. Angles of that would probably be angle 1 and angle 2. Angle 1 and angle 2 are angles of the triangles I just proved up here in DXE. And also GF and DE. Yeah. So the only step left is this one. That's congruent to itself. That supplies DF. DF, that's this thing here. That supplies the missing piece for. Now in this DEF, I have a side that I just named. I have an angle that I did up in step 5. And then this side that's congruent here in steps. That's also step 5. I actually have side angle side. Oh, it's a two-stepper, 2 triangles, and they're both side angle side. Interesting. Number 5. AB is congruent to AD. That's given. As well as BC and DC. Okay. I might have isosceles triangles here. I might just have congruent triangles here. It's hard to know. I'm trying to prove this. Sorry, this was number 1. There's 8 total. This is step 8. Okay. I'm guessing, yeah, we're going to do 2 sets of triangles here. I don't really know which set is first here because That's not my goal. My goal isn't about triangles. It's about a perpendicular here. It's probably going to be that because two angles are congruent and supplementary, then they're going to be 90, that kind of thing. Oh, this I know the reason already. Right? Just saw that. Anything else that easy? Yeah. You know what? Let's go ahead and mark this stuff. I know it's going to be useful. XC is congruent to itself. AC is congruent to itself. Oh, look. AC completes side, side, side on these triangles here, ABC. Now I have side, side, side marked. So that would, we might as well go ahead and call that. Oh, I need this first, don't I? I need that for this. Okay. It looks like I need this for something else. So we'll go ahead and wait and put that there. Okay, so is any of this stuff, now that I have congruent triangles, is there anything I can, there's probably a reason to get these triangles congruent by CPCTC for maybe one of these. BCX, yes, there it is, BCX and CXD. I probably should have called that 4, but as long as it's after this, it's okay. Great. What about, oops, I didn't do the right one. I said BCX and DXC, but that's not what this one is. That one. It's this one. I said it, I just didn't look closely at this. Okay. Now, do I have enough to say BCX? Yeah, I do, because I marked this triple thing here. Oh, why did it do that? Okay. It's, now with that marked and this CBCTC thing, I have side angle side in the little triangles down here. Then by CBCTC on those little triangles, I can say this. And since they're congruent and supplementary, implies that they must be perpendicular. Again, I keep saying that's not very popular in the test, but all this stuff up to 7 would have been good for the test. That last stuff makes it kind of tricky. Okay, 4-7, last section. Here we go. And I got about 8 minutes left. Draw the median from A. All right, so A, for a median, it has to connect to the opposite side's midpoint. So I find the midpoint, and of course this could be a construction for you. You have to construct that midpoint and then connect it to A. The altitude from A, oh, guess what? If this is isosceles, I'm already done. This midpoint, this median also happens to be the altitude. If it's isosceles, that's not always going to happen. And the perpendicular bisector of AB. It just says draw, so I'm not going to go crazy constructing. The draw that perpendicular bisector would be something like this. It's got to be the line that is perpendicular there, and this little piece has to be congruent to that little piece. So it's just a drawing, so it's not that bad. And this one, median from A, so I find the midpoint of BC, like this. And if I mark this, it means this is what I'm thinking about. Draw that to A. Altitude from A, so that's the perpendicular from A to line BC, already done. And the perpendicular bisector of AB. AB is over here, hit the midpoint and go perpendicular, something like that. Looks like it's going to hit C, but that wasn't the point. The point was just that. Okay. In the last one, median from A, so I go from A to the opposite midpoint. Midpoint looks like it's about there. Altitude from A, I go A perpendicular to line BC. That's outside the triangle here. Line BC is kind of, I can extend it as much as I want. I have to make that perpendicular. And the perpendicular bisector of AB, again, looks kind of like this. Those are kind of all the same. Whoops, I'm just trying to draw an arrowhead at the midpoint and perpendicular. Great. All right, last little bit here. If AB is if AB equals BC, then blank is a median of APC. That would be PB. We just did a bunch of stuff like that. Remember, medians are segments. If PC is perpendicular bisector of blank, I'm guessing that thing and that thing. So perpendicular bisector of BD, then right. If APD, this is probably not useful anymore. If APD is a right angle, APD, okay, then blank and blank are altitudes of APD. APD, well, PC is an altitude. Oh, it doesn't tell me. Oh, no, PC is not an altitude. I need an altitude to hit a right angle. So it'd be PD, that's an altitude from D, and AP, an altitude from A, are altitudes. PC is a median. PC is a median of BPD, this here, so that means this is a midpoint of BD. So we could say BC, no, not the little thing on top. We could say BC equals CD. If BC equals CD, and PC is perpendicular to BD, then blank is a perpendicular bisector of blank. Well, that's sort of the definition. PC is perpendicular bisector of BD. Whoa, what's happening now? All right, I'm back. It was BD. All right, PC and AC are both altitudes. PC and AC are both altitudes. Well, that means they must be right angles. Then blank is a right angle. I just marked it. ACP. Okay, because of the word altitude. Altitude implies we're talking 90 degrees. All right, this is the last little bit. I got almost 5 minutes. If BX is a bisector of ABC, like that, if those two are the same, then we got some congruent angles. Angle, I just marked it. ABX is congruent to XBC. That's old news. What's new news is this point X is equidistant from the sides. It's equidistant from the sides of this angle. The distance from X to this side is perpendicular to it, and the distance from X to the other side is also perpendicular to it. So dx is equal to gx. That is not obvious. So I'm going to have to erase this each time. If dx is the perpendicular bisector of EB, so that's have to be true, then E to D equals, well, B to D. That's not a big surprise. But also, the distance from X to each endpoint has to be the same. Okay. Whoops. I'm trying to pick up my eraser here. All right. If XB equals XF, then X must be on the perpendicular bisector of BF. So blank is the perpendicular bisector of B. Well, yeah, since it's perpendicular, I know it's the bisector. Great. XG and the XBF. Oh yeah, now we have an isosceles triangle. XBF is congruent to XFB. These are really hard. Okay, I'm glad I did these. And the very last question. XD is congruent to XG. So the distance there is the same. Then blank is the bisector of angle. Ooh, we're talking about angle bisectors. This is kind of the converse of number 1. X is equidistant from this line and this line. That means this, so it's X is on the angle bisector of that. Well, if you connect it to B, you're going to see it's that line there. So these angles are the same. So XB, start at B, go through X, is the bisector of angle ABC. I hope you enjoyed this as much as I did. That was 5 parts of review. I will see you at the test.